Today we'll discuss the first program under part A in your CN lab, that is Computer Networks lab. Okay. So first, before going to the program, first we will see which simulator we are using to simulate the program. Okay. Under this section, you have 6 programs to simulate. First, I'll take up the first one given in your syllabus. So to simulate the given problem here, we use network simulator, that is network simulator 2. So before going to the actual explanation about this network simulator, we'll see the definition of simulation. What is simulation? It is a simulation which is an approximate imitation of the operation of a process or a system. Okay, so we are just simulating the process of a real world system, or it may be a system with respect to a real world system. So what is NS2? As I said, NS2 is a network simulator. Okay, and basically it is an object oriented, discrete, event driven network simulator which is developed as UC Berkeley, which is written in C++ and OTCL. See, OTCL is object oriented tool command language. This network simulator uses tool command language scripting. Okay, so you can see here in the slide, it is a package of tools that simulates behavior of networks. So this NS2 is used to simulate the behavior of networks. So using this simulator, what operation you can perform, or what are the tasks you can do, you can see here. You can create network topologies, okay, and the log events that happens in network under any load, and also you can perform analysis with respect to the event that occurs in the network. That means you can analyze the events to understand the network behavior. Basically, this tool is used to simulate the behavior of networks, right? So this NS2 helps in analyzing the network behavior by looking at the events that happens in the network. Next, let's there are many topologies used in the network. It may be mesh, ring, bus, many more, right? Ring, many more are there. So here you can see in this topology, I've used 6 nodes, okay, and all the nodes are connected. Few links are bidirectional and few links are unidirectional, okay, and for each link I've specified the bandwidth as well as delay. For N3, between N3 and N5, the bandwidth set is 300 kbps and the delay is, or you can say latency is 100 milliseconds. So in this way, you can set up the topology using this NS2 tool. Okay, that is Network Simulator 2. So you can set up the nodes, provide the links, and you can specify the bandwidth, delay, and all other things. So this is just an example I've considered. So with respect to this topology, you can see you can create the nodes, okay, where you can set queue length and also the location of the node. You can set the protocols and the routing algorithms that you are going to use in the network. Okay, here the links provided between the nodes can be simplex, duplex, it may be wireless or wired network or satellite. Okay, you can also set the bandwidth as well as latency for the links and all these things. So whatever we saw here, the nodes, links, the setting bandwidth and the latency can be done using the TCL scripts. Okay, so NS2 make use of this TCL script. So all the programming or the coding we are going to do it using TCL. So that is tool command language. So next thing, we'll see how network behaves. So, or you if you want to analyze the network behavior, we are going to trace that event happens in the network. Okay. So if you see in this box, there are many columns here. This is one column, this is one column, this one column, this one. There are many columns here. So here you can see this particular column represents the time at which the node, from the node the packet is sent. Okay. And also you can see here one more written, that is source and destination address and port address. So all this can be recorded using ns2 simulator. Okay. So looking at this event, looking at this log, you can analyze the network behavior. Okay. So this is very important. Here you can see r is there in the first column, right? R means received packet. See, if you consider this, the received packet, a particular packet is received at this point of time from node 1, it's been sent to node 2. So node 2 received this packet and the traffic used is CBR. Okay. So in this way, you can analyze each and every event that happens in the network with the help of network simulator. Okay. So another advantage is that if you use network simulator, it will give you an animator, like the flow of packets in the network and how many nodes we have considered for the network in the network topology, and all that you can see using a NAM file, that is network animator. So here network animator helps to observe the network behavior. Okay. So you can, as I said, you can see how packet flows in the network. If there is a dropping of packets, that can also be visualized with the help of NAM file. Okay. This actually the architecture of NS2. So as I said, NS2 make use of scripting language, that is TCL, that is tool command language. This program, the program which is written in TCL format, is given as input for the NS2 shell. Okay. So NS2 shell, then when you execute the script in NS2 shell, it will generate the trace file. So the output of this simulator is trace file. Okay, we'll see what is trace file in the next slide. Okay. So with the help of this trace file, you can generate the NAM file and xgraph. Okay. The xgraph we'll see in the third program. When I discuss third program under part A, we'll see what exactly xgraph is all about. But this trace file will help you to analyze the network behavior. In the trace file, all the events that happens in the network will be recorded. Fine. So using this trace file, we can generate NAM file and the xgraph. Next, how to use this NS2. First is create topology, getting traces using NAM. Okay, so these are the initial steps. We'll see that in detail. So now, what is TCL scripting? See, this tool command language, it is a general purpose scripting language. Okay, and it also called as interpreter. Fine. It can be used in different platforms like Unix, Windows, and Mac. Okay. And see, in other programming language, we declare a data type for the variable that we define, right? Whereas in this case, it is not necessary. Okay. So these are the important 10 steps you should remember. The first one is, see, when you write TCL script, you should remember all these 10 steps. The first one is create the simulator object. Next step is open trace file. The extension of this file is filename.tr, okay, where the tracing can be done of all the events that occurs in the network. Third one is open NAM trace file, and the extension of this file is filename.nam, and turn on tracing. Fourth step is create nodes. Fifth is setup link. With respect to link, you have to specify bandwidth, latency, queue type that is used for the node. Okay, used for the link. And next thing is you have to mention or you have to configure the transport layer agent. Is it you are using TCP or the UDP? Okay, and once you're done with configuring transport layer agent, next step is configure application layer protocol. Like with respect to TCP and UDP, whatever agent that you choose in transport layer, with respect to that, the application layer protocol must be used. If you are using TCP, then use FTP. If you are using UDP, then use CBR. Okay, file transfer protocol, constant bit ratio. Okay, so once you're done with configuring all these things, next step is you have to mention when you are supposed to start the simulation, that is start time, and when you have to stop the simulation, that is end time. Okay, so after this you have to call up the finish procedure, okay, where you are specifying to close the simulation. Okay, the last step is run simulation. After after you call finish procedure, the last step is run simulation. This command should be executed. This should be included in your scripting, then only this will run the simulation. So the first step is creating simulator object. Next is open trace file and the NAM file. Once this is done, the fourth step is create nodes. Once you create the nodes, you have to link those nodes, right? So set up this link. If link is provided, specify what is bandwidth, latency, and the queue types used. Okay, and next configure transport layer agent, whether it is TCP or UDP. With respect to TCP and UDP, you have to configure the application layer protocol, whether you are using FTP or CBR. Okay, once this configuration is done, specify what is the start time and end time of the simulation. Okay, then call finish procedure, and the last step is run the simulation, that is run simulation. So now we'll see how to write this program. So whatever I explained in 10th step, I just summarized here. So the first thing we call it, as you can see here, this is creating topology. Okay, next thing is creating transport layer, configure transport layer, and then create the applications, application layer protocol. The last one is schedule events, when to start and when to stop. And the last one you can see here, you have to specify this run simulation. Okay, so first step is what? Create an object, right? So how to create an object here? See, using set command. Set is a command. I'm creating an object, that is ns. This is the object. Okay, I'm creating this object with the help of keyword new under the class simulator. So simulator is a class defined under network simulator package. Okay, so I'm creating an object ns for the class simulator. This is the first step. Next step is what? Open trace file and start tracing, right? So how to open this trace file? Set is a command used to create an object here. See, this is object. Okay, open the file out.tr. See, as I said, the extension of trace file is .tr, right? The name of the trace file I'm given here as out.tr. Open trace file in write mode. Okay, for this file, I'm creating a pointer in the name trace file. Okay, the name of the file pointer here, or you can say object here, trace file 1. Clear? And then I'm calling this trace all function with the help of created object for the simulator by calling the pointer. So this will help you to trace the event that happens in the network. Create a file, open a file, that is trace file, in write mode. Create a pointer for that. Using trace all method, start tracing. Okay. Next is open NAM file. See, like before, it's same as the trace file. Set NAM file, that means the pointer to the file outNAM, and open it in the write mode with the help of NAM trace all. That means the function used to trace happens in the network into the NAM file. Okay. And one more thing, see here, NS is object created here. NS is object created here, right? So you have to call this object here. So how do you call it? With the help of dollar symbol. So prefix dollar for the object name. That means you're calling the created object here. Okay, that is one way of calling the object. Next step is create nodes, right? So how do you create the node? See, I'm creating an object for the class node. Okay, so do remember the name of the node is n0 here. I'm creating a object that is n0 of type node. Fine. Next thing is what? You have to specify the link, right? So I'm selecting duplex link between the nodes, that is n1 and n2, or you can say n0 or n1. Okay, so I'm setting up this duplex link between these two nodes and selecting bandwidth as 10 MB, latency as 10 milliseconds, and queue type as drop tail. So what is drop tail? This drop tail actually queue mechanism which is used by the routers. Okay, that I mean it is used at the routers that when packet should be dropped. So if uh, um, router is full, that means the queue at the router is full, then some mechanism should be used to drop the packets, right? Randomly you can't drop all the packets. So a certain mechanism is followed at the queue, so that followed here is drop tail. Actually, in this drop tail, each packet is treated identically, and when queue filled to its maximum capacity, the newly coming packets are dropped until queue have sufficient space to accept incoming traffic. Okay, there are much more queuing mechanism like red, blue, deficient, round robin, many more mechanisms are there, out of which for our program we are using drop tail. So if the queue is full, whatever uh, traffic is there, incoming traffic is there, it will drop the packets. Fine. So next is queue size. You have to set up for the link between n0 and n2. See here, you have to remember this queue size of the link between n0 and n2. I'm setting it to 20. So how to do it? Call the simulated object. Use the method queueLimit. Okay. QLimit between n0 and n2 is 20. The size of the queue is 20 here. Fine. Next step, configure transport layer agent. So this is very important. First, create an object for the class TCP. See, in NS2, there are many classes predefined, okay? Out of which to set up the transport layer agent or to configure transport layer agent, I'm considering the TCP class under agent class, and for this, I'm creating an object in the name TCP. To remember, agent, TCP are the classes defined under network simulator, I mean NS2. Okay. Since I have to configure transport layer agent, I'm considering the TCP class under agent class. For this class, I'm creating an object called TCP. Okay. Any name can be given here. Fine. So once this object is created, you have to attach this TCP to particular node. I mean, which node you want to mention it as sender, or which name given to the sender. Okay, so that can be done with the help of method called attach agent. I'm attaching this TCP object to the node N0. Okay, so now N0 in the topology will act as sender and it follows TCP protocol. Fine. So once you mention which node in the network is sender, the next step is you have to specify which node will act as a receiver, I mean destination node. To do that, again, I'm creating an object for the class TCP sync, which is again defined under agent class. Okay, do remember, under agent class I'm considering TCP sync class. For this class I'm creating an object called sync. Okay, so in TCP connection, the source node will be called as source node and the destination node will be called as sync, right? So with respect to that, the name given for the object as sync here. Okay, now the next question is uh, which node, I mean the receiver node. For that you have to attach the object which you have created here. So how do you do that? Using attach agent function, I'm attaching this sync agent to node N1. Okay, so you can see here N0 is the source node, N1 is the destination node. For this source node, I'm attaching TCP. So that means this acts as a source node. And N1, for N1, I'm attaching sync object. So N1 will act as destination node. Fine. So next is I have to connect the source node and the destination node. So how to do that? With the help of connect function. Using connect function, I'm connecting TCP and sync. That means I'm connecting N0 and N1. Okay, first thing is what? Create an object under TCP class and attach that to the sender node. Okay, and again create an object for the class TCP sync and attach that sync to the destination node. Now N0 and N1, N0 is source node, N1 is destination node. Now connect those two nodes with the help of connect method. Okay, this is all about the transport layer. See, in this case, it is about TCP. What if I use UDP protocol at the transport layer configuring? So same as the previous one, but the classes are different here. So set up UDP under the class UDP, which is defined under agent. Okay. Once you create this object, attach that object to the node, that is N node, with the help of attach agent. This is source node, and now you have to specify which is the destination node. In UDP connection, the destination node is called as null. Okay, so create an object null under the class null, which in turn defined under the class agent. Okay, once you create this object, attach that object to the node which you want to call it as a receiver node. Okay, with the help of attach agent. Now N0 is source node, N2 is destination node, and I'm calling it as null node. Okay, so once you specify which is source node and the destination node, next thing is connect those two nodes with the help of function, that is connect method. Okay, with this method you can connect UDP and the null. So always remember, here while connecting, you are not supposed to mention the node N1 or N0 or N1, but you have to specify the objects that is attached to the nodes, that is UDP and null here with respect to UDP connection. What is the next step? Specify or configure application layer protocol, right? So if I'm using TCP connection in the transport layer, then the respective application layer protocol is FTP, right? That is file transfer protocol. So how to configure this? First thing is create an object for the class FTP, which is defined under the class application. Okay. So once you create this object here, attach the created object to the TCP. TCP means what? The source node, right? So I'm attaching with the help of attach agent method, I'm attaching the created object, that is FTP, to the node TCP. Now the TCP node, that is N0, will be able to generate the traffic. Why? Because I have attached this FTP object to that. Fine. Next is, what if I use UDP in the transport layer? Then the respective application layer protocol should be CBR, right? That is constant bit ratio. So how to do it? Create object under the class CBR, which is defined under the class traffic. So you have to follow the same syntax while typing this. Okay. So create an object CBR under the class CBR. Okay. This CBR class defined under the class traffic, and this traffic class defined under the class application. And do remember, this application class is defined under simulator. That is a package present in the network simulator 2. Okay, once you create this object, you have to attach this created object to the UDP. Okay, that is the source node. So attach CBR to the source node in which UDP is followed. Okay, with the help of attach agent method. Now you can see these two lines. These two lines helps in specifying the size of the packet. See, the node will send the data to the receiver node, right? So now what should be the size of the packet? Here, with respect to this example, I have specified as 100. To do that, the keyword used as packet size underscore. Leave one space and then write the number. And also for this, I have to specify, it's not mandatory, it's optional. Just for the explanation purpose, I have considered the rate, delay between the packets. So that is set as 0.01 MB. Okay. So the keyword used for this as rate underscore space and then specify the number. Okay. Next, specify start and end time. So the syntax followed for this is call the object created under simulator class. Okay. At time 0.1, I want to start the sender node to send the packets in the network. Okay. So you have to follow the same syntax, $CBR and the keyword start. It should be written in double quotes. Okay. This is about the UDP connection. Okay. What if I'm using TCP connection? For that also you should mention the start time. Okay, that is 1.0 here. And then specify the stop time for FTP and also stop time for the UDP. Fine. This is all about the start time, end time. The last but second step is finish procedure. Right. So here procedure PROC stands for procedure. Name of the procedure is finish. Okay. And you have to write the curly brace for this and again use the curly brace to write the content for this procedure. Okay. I'm considering NS, that is object created under the simulator, trace file 1, that is pointer considered for the trace file, and NAM file as pointer created for the NAM file. So with the help of global keyword, I'm considering these three objects. Okay. So now you have to close all the file pointers once if you open it, right? So that's what I'm doing here. Using flush trace method, I'm closing the trace file as well as NAM file. NS, that is the first object here created for the simulator class. I'm flushing that. That means I'm closing that, and also I'm closing the trace file pointer and also the NAM file pointer. Fine. Then execute the NAM file. That is exec is a command used to execute this NAM file, and then exit of 0. Right? And last is at what time it should finish? At 125.0. This timing is left to you to choose. So at this particular time, I want to finish this simulation. That is what I mentioned here. Okay. The last step is what? Run. So call the object created under the simulator and the command run. So when this is executed, the scripting language will start to execute. Next, see, as I said, when the scripting language is executed, the output will be trace file, isn't it? So this trace file will be having all these fields. So first field will be about event. Event includes R, D, plus, minus. Okay. So in event, these values will be recorded. R means received, packet received. D means packet dropped. Plus means enqueued. Minus means dequeued. Okay. So whether the particular packet is received or dropped or enqueued or dequeued, that data can be obtained by considering the first field. Next field is time. See at what time this particular event happened. That is recorded under this column. From node and to node. From which node to which node the packet has been traveled. That can be obtained from these two columns. Then packet type and packet size. Is it a FTP packet or a CBR packet? That can be that data can be obtained from this column or field. Okay. And the packet size, with respect to this example, I've set it to 100, right? So the packet size will be 100 here. And the flags, see, for certain, since we are not setting any parameter with respect to flag, we will not get any value here. And the next field is flow ID, next source address and the destination address, and the sequence number. The last one is packet ID. So this trace file will help us to analyze the network behavior by considering all the fields here. You can get the event, what event happened, at what time, from which node to which node the packet has been sent, what is the size of it, what is its ID, source address, destination address. Or considering all this data, you can analyze the network behavior. And do remember the output file of the NS2 is trace file, and trace file will be having all these data, or you can say all these fields. So this is simple example where N1 and N2 is considered, between which the link is provided. Bandwidth is also set, latency is also set. See, whatever I explained in the previous slides, considering that for this example, let's try to write it here. So I'm considering two nodes, N1 and N2, okay, for which the link is also set up, duplex link. Bandwidth is also set, that is 1 Mbps. Latency is also set, that is 10 Mbps. Next step is what? You have to specify whether you are using TCP or UDP, right? So N1, for this N1, I'm attaching UDP agent. Okay. So since I'm adding UDP agent for this N1 will act as source node. So other node will act as destination node. So for which I'm assigning it as null. So N1 will be UDP, N2 will be null. Okay. So I have to send data from N1 to N2 now. So what is the application layer protocol I'm supposed to specify? That is CBR. So CBR, you have to attach it to UDP. Okay. So this is just an example how simulation is done or the topology is set up in the network simulator. Okay. So directly we'll go to the program now. See, question goes like this, the first program question. Okay. Yeah. So question is, implement 3 nodes considering point-to-point network with duplex link between them, set the queue size, vary the bandwidth, and find the number of packets dropped. So in the given question, what I have said, you have to set up a point-to-point network. So topology followed as point-to-point with duplex link between the nodes, and you have to specify the queue size, bandwidth, and also you have to find out number of packets that are dropped. Okay, so let's see how to do this. What is the first step? Create an object, right? How do you create it? Using set command. Set ns, keyword is new, for the class simulator. Next, open trace file, or you can say nam file, anything. Open nam file in write mode, for which I'm creating pointer as nf. Okay, using nam trace all, start tracing. Again, open trace file in write mode, creating the file pointer nd. With the help of trace all method, start tracing. This is the first step, right? Next step is what? Creating the nodes. How many nodes they have specified in the question? They have mentioned 3 nodes we are supposed to create, right? That is N0, N1 and N2. So how do you create it? With the help of set command of type node, I'm creating this object. Or you can see I'm creating this object of type node here. Okay, so in the same way, I'm creating 3 nodes and naming it as N0, N1 and N2. Next step is what? Specify the link, right? I'm using duplex link between N1 and N2. Specify the bandwidth. Here it is 1 MB. Latency is 10 ms, 10 milliseconds, and the queue mechanism followed as drop tail. Okay, this is between N1 and N0 and N1. Similarly, specify the link between N1 and N2. Okay, so duplex link between N1 and N2, specify the bandwidth, latency, and queue mechanism. The next step is specify the queue limit between the nodes, okay, between N1 and N2, and specifying the size of the queue, that is 20. See here, N0 and N2. If I consider N0 as source, N2 as destination, N1 will act as a intermediary node, right? So that's why I'm specifying the queue size of this link. Fine. What is the next step? Specify whether you are using UDP connection or TCP connection, isn't it? So that is, you can see here, I'm considering UDP connection for this topology. So create UDP object for the class UDP and attach that created object to the node 0. Now N0 will act as source node. Okay. Once you attach transport layer protocol, next step is specify application layer protocol, isn't it? Or you can see you have to specify which node will act as a destination node. See, that is written here. Create the object sync for the class null. Okay, attach that created object to the node n2 using the method attach agent. Okay, so here I created source node, here I created the null node. Or you can, instead of sync, as I said, sync is used for TCP connection, right? See, name can be given anything. So let me write it as null here. So the same object should be called. Since I'm using UDP connection, the destination node, I'll call it as null. Attach that created object to the node N2. So N0 will act as source, N2 will act as destination. Now connect source and destination with the help of connect. So UDP 0 and created object none. So now the source and destination nodes are connected. Now the next step is you have to specify the application layer protocol, right? So since UDP I'm using in the transport layer, the respective application layer protocol is CBR. So create this object CBR for the class CBR, okay, and attach that created object, that is CBR, to UDP with the help of attach agent. See, these two lines are optional. You can write it or you can eliminate it. This will specify packet size and also delay between the packets. Okay. So once you set up configure the application layer protocol, next thing is you have to specify the start time and stop time for the event. So CBR start at 0.2 and stop at 4.5. Once you specify this, you have to finish this simulation, right? So finish should happen at time 5.0. Now finish is the procedure. The control will go to the procedure part that you have written in the program. Yeah, procedure. With the help of proc keyword, the procedure, this is the procedure name, and I'm considering the global or variables, or you can say objects created in the first step, that is NS, NF, and ND. Flush those pointers with the help of flush trace. So, and close NF and ND and execute NAM file. Then exit 0. So once this is executed, when procedure is done, the last step is execute the command run. When you execute this command, the simulation will start executing. So when you execute this program, you will ended up with trace file and also the NAM file. Okay, that will see in the next part, the execution part. Okay, see, looking at the trace file, you can't retrieve the question data that they have asked in the question. In the question, they have said to find out the dropping of packets, right? Yes. So to find out the dropping of packets, we use another program, that is awk file. Okay, this awk file, or you can say awk program or awk command, it is a scripting language used for manipulating data and generating the reports. Actually, this awk program will take input file, it performs the pattern matching based on the conditions specified in the awk program, and it will give you the result. Okay, So this awk file consists of three parts: begin section, body, and then end section. Okay, begin, body, and the end section. Begin, we will declare the required variable. See, in the question they asked you to find out dropping packets which are dropped, right? So here, so I'll consider two variable: drop packets or received count. Drop count and receive count in the beginning section, and I'll initialize it as 0. Okay, now the next thing is, see, output of the simulation program is trace file, right? In the trace file, the first field will give you the data about events, like what event happened in the network, right? So, uh, as I said in the explanation, first field in the trace file will give you the events data. Either it may be received packet, drop packet, enqueued or dequeued, right? So I have to consider the first field in the trace file. That's why I consider event is equal to $1. So $1 is nothing but the first field in the trace file. For awk file, I'm giving input file as trace file. In trace file, consider the first field, that is event. Okay. With this condition, check if event is equal to D. That means increment the drop count. If event is equal to R, then increment the receive count. Once you have this data, I'm just printing the counted value with the help of printf statement at the end section. Like you will write the same format in C language, right? In the same way, using printf statement, I'm printing the drop count and the received count. Okay, so the formula used or the command used to execute ns2 program is ns program name dot tcl. Extension of this ns2 program is file name dot tcl, and to execute this you have to use command ns program name dot tcl. When you execute this program, you will end up with the NAM file where you can see the flow, network setup and the flow of data. Okay. After this, you execute awk file. Okay. For awk file, I'm giving trace file as input. When you enter this command, or when you execute this command, the number of packets dropped and received will be shown in the output monitor. We'll see that execution part now. Now we'll see the execution of first program. I have created this program in the name 1. Okay, so I've written this program and name given as 1.tcl. So this is the code, written it. Okay, save this, close. Now you have to execute this program, right? So command used for this is ns file name 1.tcl. Okay, when you execute this, see, you can see the NAM file. This is NAM file where you can see the network. Okay, so N0, N1 and N2, 3 nodes, and this is the point-to-point link network. Duplex link followed between the nodes where bandwidth, delay, queue size and all parameters has been set. When you click on the play button here, see here, this is the timeline. We have specified the time at which the packet flow should start, right? You can see here from 0 to 1, from 1 to 2. There is flow of packets. Okay, you can see the time is flowing here. 0 is the sender, 2 is the receiver. Okay, so packets are passing via node 1. Okay, I'll just speed up this flow. I can speed up here. Okay. Yeah. This is how the NAM file looks like. Okay. The next part is what? See, when you execute TCS script, trace file will be generated, right? So the trace file, the name given in the program is prog1.tr. I'm just opening that file. See, this is the trace file where you can see the multiple columns, right? Event field, time, from node to node, traffic, packet type where CBR is used, right? And the packet size is given, flow ID and flags that we have not considered, from node, from node to node, okay, and sequence ID and the packet ID. That is what included in this trace file, okay. So plus represent the first field. See, with respect to this program, we are looking into the first field in the trace program, isn't it? So where you can see in the first column plus, minus, right, R. So we didn't see any dropping of packets in the program, right? So there is no D in this trace file. Okay. So we have to consider this field in the awk file. When you give trace file as input for the awk file, the program will consider this first column in the trace file. Wherever R and D is present, that count will be taken and displayed in the output monitor. This is all about trace file. I've already created the awk file here. So this is prog1.awk. So here you can see the begin section condition I have written and end section is also present. Okay. So for this, I have to give which file as input? Trace file. See, awk is the command. Okay. I'm giving an input file minus F specified. I'm giving an input file for the awk program. This is the awk file name for which I'm giving input file as prog1.trace, trace.tr. So when you feed this file as input to awk file, it will find out what are the packets dropped and what are the packets received. Here packet received is 1722, whereas packet dropped is 0, right? Now we'll change the bandwidth and we'll see whether we can get any drop count here. Okay, let me open the TCL program. See here, if you change the bandwidth, let me with between N1 and N2, I'll just change the bandwidth here. Instead of 512, I'll give 115. I'll give it in KB here. Okay, kilobytes. Let's see, I'm changing the bandwidth as per the question they have mentioned. Okay, let me execute the program. TCL script. Let me play this. I'll just forward it. See here you can see the flow of packets from 0 to 1 and 1 to node 2, right? Since I reduce the bandwidth here in this link, the size of the queue will be, the limit will be exceeded. That's why here the dropping of packet occurs. Or you can see, since I reduce the bandwidth of the link, there may be congestion. That's why dropping of packet is happening. Okay. So I'll just forward this. Let me close this. And now you see the trace file. This is trace file created. So in the first column, in the previous example, we didn't see any D in the first column, right? See, but whereas in this, when I change the bandwidth, I can see D in the first field. D represents packets dropped, right? So see here, plus, minus, R, D. So all four values are present. Let me execute the awk file and find out how many packets were dropped. So this is awk file executed. See here, packets dropped is 728, whereas in the previous example it is 0. Okay. In this example, packet received is 994, whereas here it is 1722. So when there was dropping of packets, when I reduce the bandwidth of the link, right? In the similarly, if you reduce the queue size or the queue limit also, you can check out do we have the packets drop or not. Here, instead of 10, I'll just give it as 3. Okay. Let us see this execution. MS to display this. Here, for this case also there is, you can see packets are dropping, right? So let me directly execute awk file. See here, I reduced the size of the queue, right? So here the packets dropped is again increased, whereas received packets are decreased. When you compare these three outputs, you can find out the difference. When you reduce the bandwidth, packets drop count is increased. When you reduce the size of the queue between the nodes, there also the packets drop count has been increased, whereas received is decreased, right? So this is all about the first program execution. Thank you.